Unit 3, but as we start Unit 5, we are going to be talking about arithmetic sequences, okay? And so a sequence, this is one of your vocab words, a sequence here is, a set of numbers in a specific order or pattern. Okay, that's the definition of sequence. So an example would be 5, 8, 11, 14, 17, and so on. So each one of those jumps is plus 3. So the increase of 3 is the pattern. Plus 3 is the pattern. Yep. Another example of this would be 8, 4, 2, 1, 1/2, 1/4. Now this is a decrease of 1/2. Okay, so both of these are the pattern that make the sequence. Okay, so there are 2 different types of sequences, or 3 different types. So we have an infinite sequence and a finite sequence. Infinite, means goes on forever. And a finite means has an ending. There's also this thing called an arithmetic sequence. An arithmetic sequence requires a common difference. Okay? So one set of common differences. So that's what we were talking about up here. So a common difference is a constant, change, either adding or subtracting. Adding or subtracting to get the next number. Next number or term. So now we're going to go into terms, and so we're going to talk about the term number. So in a sequence of numbers or a series of numbers, we are going to have different term numbers. So if I go back up to my example here, I'm going to copy this one. And I use this down here. So 5, 8, 11, 14, and 17. This is my series. This 5 is my T1 or my term 1, okay? So if I go over here, the first term in a series or sequence, sorry. So this is the starting point. All of these terms can be numbered after this. So this is T2, this is T3, this is T4, and this is T5, okay? Those little numbers are called subscripts. And they happen to be this n value here, okay? So subscripts after T that tell us what number a term is in the sequence. Okay, so when we have Tn, what we're really saying is a unknown term number. So Tn might be equal to T5. but we don't know. So that's what we're figuring out because we don't know what this n is. So we don't know what number term it is. D is our common difference or constant. So that is what I talked about up here. Okay? So I'll give you a second to write this down. Okay, so now we can use a formula. So our formula that we have, or our equation, is this one right here. So anytime we have a value or information, we can plug those numbers into this formula to solve for either our common difference, our Tn, our T1, any of that. So an example. Let's look at this one here. So it says, if I'm given this sequence, 10, 15, 20, 25, find the T7 and yeah, so we're gonna do that one. Find T7. So here, if I'm gonna plug this into the formula, I'm gonna go Tn equals T1 n minus 1 d. So Tn is gonna be T7 equals my first term, which is 10, and then n is equal to that subscript, so 7 minus 1 times my common difference, which is 5, because this goes up by 5, this goes up by 5, and this goes up by 5. So that is my common difference, so 5. Now I can solve for what my 7th term in the series would be. So I'm going to draw that back up over here. So T7 is equal to 10 times 6. Oh, thank you. Sorry. 10, that should be a plus there. 10 plus 6 times 5. So T7 is 10 plus 30, which is 40. So T7 equals 40. Now, this is telling me that the 7th term in my series is equal to 40. Let's check that out. So 10, 15, 20, 25, 30, 35, 40. I've reached 40, so now let's check this out. This is T1, T2, T3, T4, T5, T6, T7. Okay, so I can solve from calculations to get my term number there. If I wanted to solve for my Tn, okay, so if I'm going to go to the next page here, if I wanted to use that same information above but solve for Tn, what I'm going to do is have Tn equal to 10, because that's my first term, plus n minus 1, and then multiplied by my common difference there. So now I can, since I plugged in what I know, I can start to simplify. So it's going to be 10 plus 5n minus 5. Okay, because I've expanded and I've multiplied the 5 inside the brackets. And then I can go, okay, so 10 minus 5 is 5 plus 5n. And then is equal to Tn. Okay, now what I'm going to do is get my, I'm going to be left with this here. Okay, that's all I can do because I don't know Tn or n. So I can determine that Tn, whatever that term is going to be, is equal to 5 plus 5 times that same number. So if I wanted to find T15, I'm going to go T15 is equal to 5 plus 5 times 15. Okay, so 5 times 15 is what? 5 times 15 is what?
3.
5 times 15, multiply. Yep. So 5 plus 75 equals my 15th term. So what does my 15th term equal? My 15th term equals 80. So that's how you do this. You need to be able to count to find your common difference. So if I give you another sequence and I say, okay, my sequence is 12, 7, 2, and -3, ... The ... means it's an infinite sequence. Okay? And I need to find D. So you can either count, you can go, okay, 12 to 7 is what? What's the difference between 12 and 7?
5.
Yep, so -5. And then 7 to 2 is -5. So find the common difference. Well, that's -5. Or you can put it into our equation. So Tn equals T1 plus n minus 1 times by D. So if I want to find my D, I'm going to go, okay, I'm going to pick the second term in my thing. So T2 is equal to T1 plus n minus 1 D. So T2, term 2, is 7. 7 equals 12 plus my term 2, so n is 2, minus 1 D. Okay, so then I can go, okay, this one is 1, so 12 plus 1, and then this, 1 D. I did not need that second bracket there. Is equal to 7. So then I can go, okay, minus 12 from both sides. And that's going to be -5 equals 1D. Divide by 1. -5 equals D. So I can solve from calculation or just by counting. Okay.